if I want to find the ordered pair for the max or min, first of all I have to find out if it is a max or min. So the first thing to find out which one it is look at the a value. Since it's negative, you know it's sad. And if it's sad, you know that vertex is a max. So right off we know it's a max and not a min. If it was happy, it'd be a minimum. Now, to find the max or min, we're looking for a vertex. So we have to do x equals negative b, b is 10, over 2a. And when we do that, we get negative 10 over negative 10, which is, we get x equals 1. So I know my vertex or my max is going to be 1 something. That's going to be my answer. And it is a max. How do I find out the exact coordinate of that? I simply plug in 1 to the equation. And when I plug in 1, that gives me y equals 1 squared is simply going to be 1. Negative 5 times 1 is negative 5. And 5 times 1 is 10. Sorry, 10 times 1 is 5. So negative 5 plus 10 is 5. That is my vertex, also known as my maximum, because when I think about the graph, that vertex is a maximum value. It would be a minimum if it was a happy face. That's how you find max or mins. Number 2, if I want these zeros, zeros are x-intercepts. So to find x-intercepts, you have to set 0 for y and solve for x. And in the process of doing this, some of you go, how do I solve this? You have to factor. So to solve this one, you have to factor. So 2 times 6 is 12. 7 comes down. What two numbers multiply to get 12 and add to get 7? Hopefully you notice that's 4 and 3. So I have x plus 4, x plus 3. Remember that's equal to 0. We're not done because we actually have to divide by this 2. So we're going to divide both pieces by 2 because we multiplied the 2 in by the 6. Now we have to divide it back off. So I now have x plus 4 divided by 2 is 2. This is not reduced, so it jumps up front. So I have 2x plus 3. Now what I do is I set each of these equal to 0. So x plus 2 can equal 0, or 2x plus 3 could also equal 0. And we solve these. This one is a simple one. This is negative 2. When I solve this one, you might have to show your work. You minus the 3 over, and then you divide by 2. So x equals negative 3 over 2. Those are my two zeros, my two x-intercepts, the two places where the graph crosses the x-axis. Next, if I want my axis of symmetry, that is the equation x equals negative b over 2a again. It's the same equation as over here. And all you do for this one is simply plug that in. This is your b, this is your a. So it's x equals the opposite of 24 over 2 times a, which is 3. Plugging in those two numbers. So I get here x equals negative 24 over 6. And my answer is simply that. Reduce it. X equals negative 4. That is an axis of symmetry. It's a vertical line at negative 4. Now be careful, you guys. Make sure you put x equals. If you don't put x equals wrong, I'll mark you off. Don't put y equals, don't put negative 4. It is an axis of x equals negative 4. Here, these are the values of the x-intercepts. You could write these as coordinates if you want. Remember, you could write it as negative 2, 0, and negative 3 over 2, comma 0. You could write these as coordinates if so needed or desired. And the last one, if I want my y-intercepts, these are x-intercepts, these are y-intercepts. If I want y, I want y, so I'm going to plug 0 for x. If I want y, I plug 0 for x of this equation, and in the process of doing that, hopefully you realize it's just the last number. It's always going to be the last number. So my y-intercept, when I plug 0 for x, I get 7 for y, that is my y-intercept. Make sure you write it as a coordinate, 0, 7. Don't just write 7. But that's how you write a y-intercept. So you have x-intercepts, y-intercepts, axis of symmetry, and maxes and mins. Make sure you can do all that kind of stuff.